Hi, hello everyone. Welcome to IP address introduction. My name is Manny. I'm a double CCIE and lead instructor at system.ca. So in this lecture, we are going to talk about IP addressing, mainly IPv4 addressing. So there are two types of IP addresses. One is current IPv4 address. Other one is new IPv6 address. We'll be covering IPv6 address in a later session. So what is an IP address? IP stands for Internet Protocol. It is like a mailing address. So IP address is like a mailing address. It is an address given to network devices. Most of the time, the servers on the internet or your home router or your laptop or PC or iPad or any kind of a Internet of Things devices, whenever you want to go to internet, you must have an IP address. There are different names given to IP addressing. So something called software address, logical address, layer 3 address, network address. So IP address can be given in different names. And how IP address look like? IP address look like kind of a 32-bit addressing schema. So remember, later we are going to study IPv6 addressing. The main difference is IPv4 address is 32-bit. So IPv4 address is 32-bit. On the other hand, IPv6 address is 128-bit. That's the difference between V4 and V6. So the 32-bit you normally write in 2 octets or 4 octets. Sometimes it is called dotted decimal notation. This is the example: 150.70.90. So there are 4 octet. Octet number 1, octet number 2, octet number 3, octet number 4. This octet is, every octet is 8-bit, 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 8-bit. So you get total of 32-bit. Sometimes it is called 4 octet, or normally people call as dotted decimal notation. The 100 is not 100. The computer don't understand decimal. Computer, you have to convert the decimal to binary. So converting 100 becomes something like this. We'll talk about this one very soon. Okay. So again, this is 128, 64, 32, 64, 32, 16, 8, 4, 2, 1. It's starting from 128. It going kind of a lowering. So you can see I'm just minimizing by dividing by 2. So there are 8 numbers. Okay, there's a 8, 7, 6, 5, 4, 3, 2, 1. Okay, so we'll talk about this one later. But remember, IP addressing written as decimal number, but technically it is converted to binary number because computer understand only binary. Okay, so the main difference, decimal is to the base 10 and binary is to the power of base 2. Okay. IP addressing can be, there are 5 classes industry defining as IP address. There is a class A, class B, class C, class D and class E. We'll come back to this one soon too. Again, the ABC is heavily used in the industry. They can be public IP addressing or they can be private and public IP addressing. So most of the time, internet we are using public IP, but at our home we are using private IP. The different public IP is on the internet, private IP is local. And also class D is called multicast addressing. That means mainly used for group communication, and class E is mainly used for experimental bit. So now where the people are getting IP address, because we know every home should have a public IP address. Okay, so it is coming from organization called IANA. So IANA stands for Internet Assigned Number Authority. They control the full public IP address space. They work with regional RIR. They work with regional RIR. RIR work with ISPs. ISPs work with customers. That means you and me. So internet, definition of internet is nothing but connected ISPs together. So guys, I have another YouTube video in my channel. It's called Internet 101. Please watch that one to get the idea behind what is internet. Okay. So hopefully you guys are enjoying. Let's keep on continue because I want to make this video kind of not too high, like within 15 minutes. Okay. So this is example of internet. You have router, you have server, you have PC, you have firewall, you have an iPad, everything connected to internet. That means every device connected need an IP address. IP address help them to communicate to outside world. That means to talk. Okay. So we'll keep on go. So now we are going to go become more technical right now. Okay. So look at this space. So these are the one binary I was telling you about before. Okay. So you have to understand this one. So if you are going for any kind of certification, for example, CCNA or any other IP certification, you must understand IP addressing and subnetting. In this short video, I'm covering introduction to IP addressing, and in a subsequent video, I'll be covering subnetting. So at least give you guys taste, okay? Then you can study. So just see bit number 1, 2, 3, 4, 5, 6, 7, 8. Then 2 to the power of 0. Remember, anything to the power of 0 is 1. Many to the power of 0 is 1, okay? Then 2 power 1, 2 power 2, 2 power 3. When I say 2 power 3, that is 2 times 2 times 2. 2 times 2 power 2 means 2 times 2. 2 power 4 means 2 times 2 times 2 times 2. So that way you can fill it up, okay? So the way I remember 128, then I remember 64, then 32, then 16, then 8, 4, 2, 1. So if you remember 128, you can divide it by 2 and you can remember. That's my style, but some people, they remember from 1, 2, 4, 8, 16, 32, 64, 128. Remember guys, earlier I said the IP address is 100.50.70.90. Now we'll see how computer understand 100. If you want to convert to binary, you have to see what is 100. 100 is 64 plus 32 is 96. 96 and 4 is 100. Now everything becomes zeros. You see, if I want to convert it 50, 50 is not 128, not 64, but 32 plus 16 is 48, 48 plus 2. You see, then 70, 128 will not come, but 64 will come. 64 plus 6, okay, 6 is 4 and 2 is 6. So you put 1, 1, then everything becomes 0. So technically, if I want to add everything, so if I add 128, 64, if I put all ones, okay, in the binary term, if I put all 1, so when you add everything, answer is 255, okay. There is a magic. I want to show you a magic also. Guys, what is 1 plus 2? It is 3. 3 is 4 divided by the 4 minus 1. What is 4 plus 2 plus 1? It is 7. 7 is 1 less than 8. Okay. What is 8 plus? So 8 plus 4 plus 2 plus 1? It is 15. It is 1 less than this number. So the same way, if I add everything, okay, if I add everything, you can add and see. The answer is 127. Okay. 127 plus this 128, answer become 255. So remember, when you add everything, it becomes 255. Okay. So if I put all 1, answer is 255. So let's keep on go, because we try to rewatch if you want to know more. Now this chart is very important. Again, doesn't matter whether you are studying new to the industry, CCNA, CCNP, or whatever certification you are doing, or even for general studies, this is very important chart. So there is 5 classes of address, as I told you before, A, B, C, D, E. So by looking at the binary number or decimal number, you can figure out if the addressing starting from 1 to 126 is called class A, 128 to 191 is called class B, 192 to 223 class C, and multicasting is special. It is 224 to 239 is so if it is 224 to 239 is called class D. If it is E, it is experimental. Now we'll focus on only these 3 guys. Okay, look at this one. In binary, if you're starting from all zeros, if the first number start with 0, is a class A. Okay, so binary can be all 0, then here 0, 1, 1, 1. Those are the space. Okay, in the case of class B, 10, if the address is starting with 10, is class B, or 128, 191. Okay, or for class A, it is 110. So remember guys, there is something called subnet mask. In IP addressing, there is something called subnet mask. Again, we'll come back to this one soon. So for class A, default subnet mask is 255000. That means this is the network ID. These are called host ID. So there is something called host ID and network ID. Network ID is nothing but ID given to the wire. Host ID is nothing but the number of IPs, number of PCs. Okay. For class B, it is 255.255. Okay. Then 00. So that means there are two network and two host. For class C, it is 255.255.255.0. So basically, there are three octet for network and one octet for host ID. So you have to know, like when you add, so there are 8 ones, so we call /8. There are 8 plus 8, 16 one, we call /16. There is 8 plus 8 plus 8, 24 ones, we call as /24. Okay. And now number of network, it become now too technical a little bit. Number of, so in the network, you remove 0, there are 2 power 7. So in the 16, you remove this -2, it becomes 2 power 14. Here in 24, you remove these 3, it becomes 21. But host, you count 0. How many 0 you have? You have total of 24 zeros here. You have 16 0, 8 plus 8, because remember 0 mean not 0, 0 8 times. Okay, 0 0 0 0. So this 0 mean it is 0 0 0 0 0 0 0 0. Okay, so this is 16 0. Here you have 8 0. So there's something called network and host. We'll come back, guys, but make sure you understand this chart. You should understand what is decimal range as well as subnet mask and etc. And you can see I'm not using 127 here because 127 is termed as some kind of a loopback addressing. And also to find the class of IP address, you must find the first number. Okay. Again, class A is very hard to get from ISPs. So you have to understand class A is very hard to get from ISPs. Now this small exercise. Okay, let's find this small exercise. So I'm writing a couple of IPs. So you're only looking at the first number. You're looking at the first number. So remember earlier I said A is nothing but 1 to 126. B is nothing but 128 to 191. C is nothing but 192 to 223. You have to memorize this one. Okay. So look at the 100. 100 is between 1 to 126. So it's a class A. 210. It is between 192 to 223. So it's class C. 150 is a class B because it is between these two numbers. Just see, I'm writing here. I'm not looking at the number. So when somebody give an IP address, by looking at the first number, you should be able to tell what class is that one. Okay. So guys, good chart. I'm not going to go through everything, but I'll go through the last one. 130 is between 128 and 191. So it's a class B. But 125 is between 1 and 126. So it's class A. 180 is between 128 and 191. So it's class B. So by looking at the first number, you should be able to figure out. Okay. So now some facts of IPv4 addressing. So IP address can be, we know it can be 0 to 255. The reason these numbers can be either zeros. It can be either, if you put 0, it becomes 0. If you put 1 everything, it become 255. Okay. So IP addressing cannot be more than 255. Here, for example, 200, 100, 1.111 is a correct IP address because everything is less than 255. On the other hand, this is an incorrect IP address because there is a 320. And remember, as I told you earlier, decimal to the base 10 and binary is to the base 2. Okay. So very important, guys. So guys, take your time and go through this one. And now couple of more technical. IP address has 2 parts. What is that 2 parts? There is something called network portion and host portion, sometimes called network ID and host ID. So what is determining which part is a network ID and which part is a host ID? The subnet mask. Okay. So remember, the main advantage of subnet mask is defining which part is a network ID, which part is a host ID. So we'll go to the live example here. So if you look at here, I'm giving IP address 150.70.90, but I'm putting subnet mask as 255.0.0.0. So that means, because this is 1, so from left to right is 1, this is called my network ID. Okay. And if I count zeros, and this is called my host ID. Okay. For normally for class A, the first number is a network ID, The second part is the host ID. Network ID is nothing but ID given to the wire. Okay, this ID of the wire is network ID. Let's look into the example number 2. So example number 2 has class B address 150.50.70.90. So because subnet mask is 255.255.00, my network ID is 150.50. Okay, then other one become host ID. So if I have a wire, the ID of the wire become 150.50.00. So ID of the wire. So for example, network ID is nothing but 150.50.00. So we'll be doing lots of calculation later, guys. For time being, we'll keep on go through the introduction here. Okay, so now, as I said, subnet mask is very important. So you already know this one, 128.64.32.16.8.421. I will ask you to memorize another one. Okay, what is 128 plus 64? Answer is 192. What is 192 plus 32? It is 224. 224 plus 16 is 240. Then 248. Then 252. Then 254. Then 255. So these both are very important. One is called subnet size. So when we do in the next video, I'm going to explain subnet IP subnetting. So this is very important, and this is very, very important. Both are important. Take your time, write down a couple of times to understand subnet size and subnet mask. Okay. So now, so what are the different? So I'm explaining in the sheet even more. Okay, just see this one now here. If it is 1 and 70 is 128, 2 ones is 192, 3 ones 224, 4 ones, 5 ones, 6 ones, 7 ones, they are all subnetting, and these are the subnet sizes. Okay, so the formula is subnet size is 256 minus subnet mask. So when you do 256, so these are all 256 minus this number, 256 minus this number, you get this number. Okay, subnet size. So note, in an IP address, subnet mask help to identify which part is a network portion, which part is a host portion. Subnet mask can be dotted decimal notation, something like this, 255.255.00, or it can be /16. So you can pay whatever way you want. Okay, if you put slash direction, is called CIDR notation. CIDR stand for classless notation actually, and also it can be decimal notation or classless interdomain routing notation. Okay, there are 2 ways you can define subnet masking. So let's go further, guys. So look at this one. These are some examples of subnet mask. Normally we know /8, /16, /24, they are defaults. Okay, 255.0.0.0, 16 mean 255.255.0.0, 24 mean 255.255.255.0. Basically you have to write down like this, and please try to write this one and exercise by yourself. You should know these ones. Okay, so you have to know what is /11. So as long as you remember the whatever we wrote. Okay, one number is 128, one number is 128, then 192, 224, 240, 248, 252, 254, and 255. So it's coming from the previous chart. I always remember the way I'm writing right now. Okay, so this is easy method. Okay, so 11 is nothing but 8 plus 3 plus 0 plus 0. So 3 is 224. That's why I'm putting 224. 15 is 8 plus 7. 7 is 254. Okay, so let's pick this one, 21. 8 plus 8 plus 5 plus 0. So 5 is 248. Okay, then let's pick this one now, 27. 8 plus 8 plus 8 plus 3. 3 mean 224. Just see. So 29 is nothing but 8 plus 8 plus 8 plus 5. 5 is 248. 30 is 8 plus 8 plus 8 plus 6. 6 is 252. So guys, this is very important. You have to know when they give in a CIDR notation, how to write the expanded notation and how to put the decimal number for that binary. So this is decimal number for the binary, guys. Okay, so very important. Try to understand this one also. Okay, So let's do one more next slide, then we'll finish this lecture, then we'll start with a different lecture. And also remember, there is something called every IP address has network ID, broadcast IP, valid IP and default gateway. Network ID is ID given to the network. Broadcast ID. Okay, what is a broadcast ID? Whenever you send traffic to the broadcast ID, it goes to all the devices in the network. If I want to talk to everybody, right now I'm doing broadcasting because I'm talking to everybody on the YouTube. Okay. Valid IP is nothing but home address. What are the valid home addresses? Okay. And remember, IP addressing is like a mailing address. You want to send information to a server to server. Default gateway, basically, if you want to go out of your network, you have to have a default gateway. If you don't have a default gateway, you can't go out. You should know, if I want to go to outside my house, I should go to the door. Door become my default gateway. Something like that. Okay. Normally, you might see, so we are going to look at two examples. Example number one. Okay. I think we'll change the color a bit. Okay. Yeah. Example number one, just see IP address is 10.10.10.15. Subnet mask is 255.0.0.0. Default gateway is 10.10.10.1. So by looking at the first number, we know it's a class A because it is 1 to 126. Look at this diagram. That means the network ID is 10.0.0.0 because they are all here. 10.0.0.0 is a network ID. So network ID is ID of the network. Okay. Then there is a default gateway. Default gateway means the route IP address 10.10.10.1. The value, then the PCs can have maybe .2, .3, .4, .5, .6. Okay, so 10.10.10.1, 10.10.10.2, 3, 4, 5, 6. But you must define within the PC, every PC, you must define IP address, subnet mask and default gateway. So to talk among themselves, they don't have to go out. But if they want to go to internet, they will go to the router. And router will be doing some other function. You'll be learning in CCNA or A+. They are called something called NATing and DHCP. So we'll talk about that one later. Example number 2, that's the last section before we start the new video session. It's a class B. Just see one, by looking at the first number, we know it's a class B because that number is class B. The reason it is 128 to 191. Okay. The default subnet mask is 255.255.0.0. The default gateway should be the route IP address. Same thing. This should be the network ID should be 150.10.0.0. Okay. This coming from the previous example. I had to change it. Okay. So this is the network ID. The valid IP is 150.10.0.1 to 150.10.255.254. Okay. Then this is the subnet mask. This is a default gateway. Then they goes to internet. Guys, I think you guys enjoyed this quick session actually. So we'll be meeting you on a next video very soon. Okay. And also, if you guys enjoyed this particular video, please subscribe to the YouTube channel. I'll be putting new videos also. And also remember guys, CCNA is very important. And if you want any information, you can reach us also. Okay. So my next session will be IP subnetting introduction. We'll meet you on a different video, and thank you and good luck in your career. Bye bye.